WagWan everybody, it's your boy Mr. Ace. Today I'll be working on a question of pH and buffers. So I have a question given to me. A buffer is made from 60 mils of ammonia and 40 mils of ammonium chloride. Where's the pH of the buffer? And they've given me the Kb. So the first step is find the number of moles because this is an additive, so there's going to be a new volume, but remember, number of moles always remains the same. So finding the number of moles will help. So find for NH3, it's going to be N is equal to CV. Make sure to convert milliliters into liters because liters is the SI units. So it's going to be 0.06 times 0.1 molarity, going to give us 0.006. Same thing for ammonium chloride. N is equal to CV. This is 0.04 times 0.1. Give us 0.004. Okay, remember these are the number of moles. Now the new volume is going to be equal to 60 plus 40 milliliters. Going to give us 100 milliliters. Converting that into liters is going to be 0.1 liters. Now the new concentration is going to be, I like to use square brackets to denote concentration. It's just going to be equal to moles. We already know the equation, so N is equal to CV. My new concentration is therefore just going to be equal to N over V, which is for, in this case, for ammonia, it's just going to be 0.006 divided by 0.1. And the concentration is 0.06. And same thing for ammonium chloride. I'm just going to quickly do it. This is going to be the same method. It'll be 0.004 divided by 0.1 gives us 0.04. Okay, now we're going to use the ice table. Write down the equation first. So we know that NH3 dissociates with water, okay, to give us NH4 plus OH minus. Okay, that's one equation, and the other equation, which I know, is that NH4Cl was going to partially dissociate and give us NH4 plus ions and chloride ions as well in water. Okay, so to make the ice table, I'm just going to use the main number one equation, which is the ammonia dissociation equation, because NH4 plus comes mostly from my ammonium chloride. It is not coming from NH3. So rewrite that again. It's going to be NH4 plus OH minus, and my ice table, ICNE. My initial here is 0.06. We're going to ignore water, and the initial for ammonium ion is 0.04. The concentration here is after the addition of my ammonium chloride. It's going to be minus X. Here it's going to be plus X. So this is going to be equal to at the end result is going to be 0.06 minus X, and this is going to be 0.04. Whoops, plus X. And here the OH minus ion is just going to be plus X, and it's going to remain plus X. So now we know our Kb for ammonia. It was given to us in the equation as 1.8 into 10 to the power of -5. So the Kb equation is products over reactants in terms of their concentration. So this is going to be NH4 plus OH minus divided by NH3. Substituting everything in the equation is going to give us 0.04 plus X times X divided by 0.06 minus X. Okay, so now because we know that X is so extremely small than 0.04 or even 0.06, we can consider it negligible. So we can remove this, and we'll be left with an equation 0.04 times X divided by 0.06, and substituting the Kb will be 1.8 into 10 to the power -5. Now, to solve for X, I'm sure that we all can do it. X is going to roughly be equal to 2.7 into 10 to the power of -5. So you can see from here that 10 to the power of -5 shows that X is so small. Finding the POH, is just going to be equal to 14 minus the negative log of your OH concentration, which we just found was X right here. And substituting everything here, it's going to be equal to 14 minus 14 minus 4.57. It's going to be equal to 9.43. I hope you all understood that. If you have any questions, please leave them in the comments, and I'll see you on the next one.